Hello dear students, I am Abhinav Sir. Welcome you all on Result 10. I hope everyone is doing fantastic. And in this rank up series, today we will be doing RCC. Okay, you can join my Telegram group Civil by Abhinav Sir, guys. Already more than 6,000 plus students have joined. Okay, the link is in the description box. You can join me there. Okay, you can download Resultant app. You can go to the Play Store and on the search option you can write Resultant Civil. Okay, on the Play Store you can write Resultant Civil and you can download our app. So we have done fluid mechanics, we have done soil, will be taking shortly in a couple of days. Surveying we have done. Now today is RCC. Then these subjects will be done. This will be on YouTube at 8 p.m. Okay, this series will be on YouTube at 8 p.m. All those students who are interested to join the crash course, the price is now 3,500. You can join the crash course for 2025 students, and those who are preparing for 26 and 27, 2026 and 27, we have the complete course where you will be getting live plus recorded classes for each subject. You will be getting study notes for every subject, PYQ for every subject, doubt sessions, test series, and workbook which includes MCQ, MSQ, NAT. Hi Nishant, Anantma, very good evening. How are you all? I hope audio video is fine, huh? Yeah, it's looking fine. You can download the app from the Play Store, Resultant Civil and Resultant Civil app from the Play Store. Okay, first of all, we'll be doing some easy questions. Then we'll be going for the 2-mark MSQ question. So initially, you will be getting some 1-mark question, majorly from the codal values. Internal radius of the bend of hooks of deformed bar should be for mild steel. Come on. What will be the internal bar for mild steel? For mild steel, guys. Remember, I am asking for mild steel. Everyone. For mild steel, the internal radius of bend. For mild steel, it is 2 times of die of bar. 2 times of die of bar. Can you tell me for cold work steel? For cold work steel, what is the value? What is the value for cold work steel? It is 4-5. Okay, although it is asked for mild steel here. Minimum tension steel in RCC beam needs to be provided for. Why that minimum steel is provided? Everyone. Otherwise, it will be to prevent the sudden failure. If there will be excessive concrete and less steel, then brittle failure chances will be there. Okay, so minimum tension steel will provide to prevent the sudden failure. Also, guys, cracking is also the answer, but the prime answer is to, otherwise it will be brittle failure due to excessive concrete. Cracking is also the answer. The primary answer is prevent the sudden failure. The utilization of concrete in tension zone of pre-stressed concrete member saves concrete range between. Okay, the utilization of concrete in tension zone of pre-stressed concrete member saves concrete range. How much concrete is approximately saved? How much concrete is approximately saved? It is 15 to 30%. 15 to 30%. The bond strength of concrete increases with. The bond strength of concrete increases with. Hi Krupa. Tell me please. The bond strength of concrete increases with the grade of concrete. With more grade of concrete, the bond strength will be more. With the more grade of concrete, the bond strength will be more. Okay. The actual neutral axis of under reinforced section. Under reinforced section. This will be easy for all, yaar. This will be a easy question. The actual neutral axis of under reinforced section will be, when the steel will be less, center of mass will be above, na? So it will be above the neutral axis. Yes. For balanced section, it will be on critical axis, and for over reinforced section, it will be below the critical axis. Okay. So answer will be C. The maximum permissible eccentricity of a retaining wall of width B to avoid the failure in tension zone. This is, you can say, of strength of material question also. Strength of material question also. What is the eccentricity for no tension? Why no tension? Because brittle materials are weak in tension. Like concrete is a brittle material, na? So they are weak in tension. The minimum eccentricity is B by 6, na? Middle third rule. Okay, B by 6 here and B by 6 here. So B by 6 here, B by 6 here. Total it is B by 3. So eccentricity should not be B by 6. Similarly, if this length is D, so D by 6 here and D by 6 here. Total will be D by 3 and that becomes a rhombus, kern. Remember? So for no tension it is B by 6. We can derive that also. Okay, that the direct stress should be more than or equal to bending stress. From there this value comes. The diameter of the column head support of a flat slab is generally kept. Tell me. Tell me please. The diameter is 0.25 times of the span length. The diameter of the column head, not column. The diameter of the column head is generally taken as 0.25 times of the span length. For a singly reinforced balanced section, the MU limiting is QBD square, or you can say RU limiting BD square. Okay, you can say QBD square or RU limiting BD square. Okay, for M20 and FE415, what is that value? For M20 and FE415, you can put in the formula and get the value. What is the value? It is 2.761. No, Wasim, it will be 2.761. It will be 2.761. In the presence of seawater and soil and water of corrosive characters, the cover of structural member should be increased by how much the cover should be increased? Again the codal provision. Again the codal provision. The cover over the structural member should increase by 12 mm. The main reinforcement of RCC slab consists of 10 mm bar at 100 mm spacing. If it is instead of 10 mm na, the 10 mm bar was at 100 mm spacing. Okay, phi is 10 mm and center to center spacing is 100 mm. Now instead of this we are replacing by a 12 mm bar, a thicker bar, a thicker bar, a thicker bar. Then what will be the spacing? Spacing can be more na, because it is more steel. If phi is 12 mm, then what will be the center of center spacing? Please take your calculators out. Please take your calculators out, guys. First of all, you can calculate AST. AST for this 10 mm bar, pi by 4 into 10 square, and in 1 meter or in 1000 mm, in 1000 mm there will be 10 bars. I am doing calculation for 1000 mm. There will be 10 bars because in 100 mm spacing na. So 1000 mm there will be 10 bars. So area of steel in 1000 mm. In 1000 mm there will be 10 such bars. Correct? Now again here also the AST has to be same. Here also the AST has to be same. Correct or not? Have you, any one of you got the answer? What will be the spacing of 12 mm? Spacing of 12 mm. Here how it will be 1000 divided by area. So area will be this. The both has to match, na? Not getting. Guys, it is purely aptitude question, na? Purely aptitude question. A number of bars of 12 mm is equal to AST, that is 10 into pi by 4 into 10 square. Okay, 10 into pi by 4 into 10 square upon pi by 4 into 12 square. This is the number of bars for 12 mm, na? What we have done, we have equated the AST. So here the AST is this into 10. Here it will be pi by 4 into 12 square into number of bars. Both has to be same, na? AST of this is 10 into pi by 4 into 10 square. AST of this yellow bars is number of bars into this. So we equated this. So number of bars will be calculated from here, and spacing will be 1000 upon number of bars. 1000 upon number of bars you can calculate. So from here, guys, the answer will be 144 mm. Answer will be 144 mm. So nearest option will be C. Okay, we have to provide the lesser than that, na? So we are safe. We have to provide lesser than that, na? So that we are safe. Give me yes or no. Give me yes or no. Everyone. Okay. Age factor for gain in strength of concrete after 6 months. Let me write all the values here. Age of concrete, because here it is 6 months, but in exam they can ask for any value, na? And age factor. So for 7 days, it is 0.65 to 0.7. For 1 month, it is 1.0. For 3 months, it is 1.10. For 6 months, it is 1.15. For 12 months, it is 1.20. So our will be 1.15. Yes, Nishant, Wasim. Now if MT is torsional moment and TU is the bending moment and MU is the factored bending moment at the cross section, flexural compression reinforcement is provided when? Flexural compression is provided at which case? It is provided when MT is greater than MU. Okay, that is the torsional moment is greater than the factored bending moment. Then only on the compression side we provide the reinforcement. Great. Shall we now move to the 2-mark question? Shall we now move to the 2-mark questions? All these will be the MSQs now. This is the MSQ. All the questions from here onwards will be MSQ. Hit them well. Hit them. Shear strength of concrete. Shear strength of concrete depends on which of the following factors? From table 19 you can see, na? From table 19 of our code is IS 456:2000. The shear strength of concrete is depending on compressive strength of the concrete and percentage of longitudinal reinforcement, B and C. Okay, again a MSQ. A T-beam, let us make the beam, having an effective flange width of 2500 mm. The BF value is 2500 mm. Okay, and the ultimate moment it has to support is 1200 kilonewton meter. The thickness of flange is 150 mm. The thickness of the flange is 150 mm. And the width of the rib is 300 mm. Width of the rib is 300 mm and the effective depth is 900 mm. Suppose here will be some reinforcement. So effective width is 900 mm. M20 and Fe250 steel. So where the neutral axis will be lie? So let us assume neutral axis lies in flange. Okay, here. So then it will be acting like a rectangular section, na? Then it will be acting like a rectangular section, na? Why? Because the concrete below the neutral axis will be neglected. So even if it is a big like this rectangular section or a T section, both are same, because concrete anyhow is neglected below that. Okay, so tell me, solve it and let me know the answers. What will be the value of mu? 0.36 FCK into B into XU into lever arm, D minus 0.42 XU, and this should be equal to 1200 into 10 to the power 6. All the values are given except XU. So XU will be getting from here 76.83 mm. So this 76.83 is less than 150, na? So assumption okay. Okay, assumption is okay. Now what will be the XU limiting? This is Fe250, na? So Fe250, it will be 0.53 into D. So this value comes to be 477. So our XU is less than XU limiting. Our is 76.83. XU limiting is 477. So it is under reinforced section. So D will be wrong. Now the answer for this will be either AB or ABC. So for 12,000, apply the formula here. 0.36 FCK into B into D XU is 0.87 FY AST. From here find AST. AST is coming to be how much? 6358 mm square. So C will also be the correct. So answer will be A, B, C. Give me yes or no. Please give me yes or no. Okay. Now, what are the load combinations possible? This I have done in the class as well. What are the various load combinations that are possible? You should be knowing that table for this. You should be knowing that table for this. It is what? For limit state of collapse. This is again MSQ. For limit state of collapse, not serviceability. So load combination. Here dead load, imposed load, wind load and earthquake load. That is a table given in IS code, na? So load combination when dead load and imposed load. So here it is 1.5, 1.5 and like this. When it is dead load plus either wind load or the earthquake load, whichever is bigger, so here it is 1.5 or 0.9 in case of reversal of loading, and 1.5. I'm not writing the limit state of serviceability values. Then dead load, all three are there, dead load plus imposed load and either a greater of wind load and earthquake load. Here it is 1.2, 1.2, 1.2. So what are the combinations that are possible now? 0.9 dead load and 1.5 of wind load. Yes, it is possible. In this case, 1.5 of dead load, 1.5 of wind load, 1.5 of dead load and yes, in this case also it is possible. 1.5 of all, no, there is no combination of 1.5 of all, but 1.2 of all, dead load, imposed load, wind load is there. So AB de Villiers will be the answer. AB de Villiers will be the answer. Give me yes or no, please. Give me yes or no. Everyone. Any doubt? Anantma deleted. Okay. This one. About the cracks. Come on. Flexure shear failure occurs under large bending moment and less shear force. No, not large bending moment less, it is zero shear force. Not less. Cracks are 90 degree with the horizontal. Yes, guys, when only the bending stress will be there, na. So of course the failure, when these kind of stresses will be acting, it will be 90 degree. Flexure shear failure occurs when span to effective depth ratio is less than 1. It is occurs when it is greater than, okay. Flexure shear failure when span to depth ratio is here, it is nothing written. What is the misprint? Let me correct it. It is 2.5. It is 2.5. Yes. So B and D will be the answers. Do this. A beam whose effective span is L and effective depth is D and overall depth is capital D will be considered to be a D beam when the ratio of, this is given, come on, when the beam will be considered a D beam. When the beam will be considered a D beam. When it is less than 2 for simply supported and is less than 2.5 for continuous beam. B and D. B and D. Okay. So others also, again hook wala we have already done. So this will be your homework. Again MSQ question. Okay, all the students who are preparing for 26, they can take our course from Resultant Civil app, where they will be getting the complete live plus recorded classes, study notes, PYQs, doubt session and test series. For any doubt, you can connect me here guys in this number. Okay, PDF I am sharing in the Telegram group. Today I am not bit well, so less number of questions. From tomorrow we'll be having the complete session. Okay, little fever and cold is there, so less number of questions, but from tomorrow we'll be doing complete practice. Thank you everyone. Thank you. Take care. Thank you.